Hello dear friends and welcome to this video today, and we shall be looking at the correction of the GCE A-Level Physics 2022 paper 2 question 1, and then we start with the analysis of the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, isn't that spitting slow, speaking fast, I could roast, I could gas, think I'm okay at last, but I don't know if that
okay, now let's look at the first question. Say that the energy generated per unit time by wind turbine is given by the equation C equal to 1/2 or A KV cube N, where rho is the air density, A is the area swept by the blade, B is the wind velocity, K is the coefficient of performance, and the N is the generator efficiency. Now, the A part is saying that we should explain with the help of an example why homogeneity of a physical equation is not a sufficient condition for the correctness of the equation. Then the B part is asking us to determine the base rate of K. Okay, now here's the question. I don't know if that's clear for you to see, but that's the question as it is. Alright, let's just give it aside and the team can answer the question. So now, we want us to determine with the aid of an example why homogeneity is not a sufficient condition for an equation to be correct. So we are going to start. So it is not a sufficient condition for an equation to be correct because homogeneity, please observe the first one A, that because homogeneity cannot test for the presence of wrong unitless constants. Yeah, so that's what we can say. And if you're being asked to give two reasons, you can say that it cannot test for missing terms of an equation. Please, I'll give an example later on. Now to give an example about this, we can just take for instance the equation, the kinetic energy Ke equals 1/2 mv squared, where Ke is the kinetic energy of a moving body, then 1/2 is a constant, then m is the mass of the body, then v is the velocity at which the body is moving. Please always define your symbols. We can tell them that the absence of this 1/2 makes this equation homogeneous but physically not correct. Okay, yes, that the absence of this 1/2 makes the equation homogeneous, yes, but physically not correct. We can include other examples, like we can bring forth other examples like v squared equals u squared plus 2as, where v is the final velocity of a moving body, then u is the initial velocity, a is the acceleration of that body, s is the distance covered by that body. Now we can tell them that the absence of these two now makes that make this equation homogeneous but incorrect. Now if we take away this u squared, we'll see that this equation will still be homogeneous but not correct. Yes, not correct. So that's how we can answer the A part. Now the B part, let's look at the B part. The B part simply wants us to determine the value of K, to determine the base units of the constant K. And the question has told us initially that this N is a coefficient of performance and as well as it's unitless. Now since E is equal to, we have 1/2 rho A K V cube N, that therefore implies that if I make K the subject here, I'm going to have my K to be equal to 2E all that on all that on, I'm going to have raw a v cube n. Now I'll tell them that k is unitless. Yes, k is unitless. Good. Now I also tell them that 2 as well is what? Unitless. 2 is unitless. Then I can start by telling them that units of E is equal to what? I know that the question gave us E. The question defined E as what? As the energy generated per unit time. So this E stands for energy generated per unit time, not just energy. So it is going to what? Energy over time. And we know that energy, we can get energy by just simply taking the force times what? The distance. Right? But I'll just cancel this because if I say unit of E, what should be this way must be a unit of something. So I know that E is equal to what? Force times distance. Since it is energy per unit time, I'm going to divide all through by time. Right? Cool. That therefore implies the units of E now is the same like what? The units of, I'll just put everything inside, units of the force times distance, all that on time. Please make sure you define what this F, this D and this T stand for. Okay, make sure you define it on the day of the exam. Now that therefore implies now that my units of E now turns out to be, the unit of force is what? Is the newtons, right? But we can still split the newtons as what? As kilograms meters per second squared. Then the distance is in what? In meters. The time is in seconds. So this unit, this simply gives me the kilograms meters squared seconds to the minus 3. Good. So these are the units of E. Now units of A is equal to what? Meters squared, because we said A is the area swept, right? Then the units of V cube, because we said V is the speed, yeah, V is the wind speed, so this is going to be meters cube per cubic second, because the unit of V is meters per second. Then if you cube all through, you are going to have meters cube second cube per cubic second. Then now we are going to have the units of the air density raw, which is going to give us, we know that density is mass per unit volume, right? So we're going to take the mass, which is kilograms, all over the volume, which is per cubic meters. Yeah, so this is a base unit of raw. Now I think we have everything that it takes for us to get the units of K. So we're going to say that units of K now is just equal to the units of, we put everything we had here initially. If we put everything, we're just going to have units of 2E, even though this 2 is a unitless constant, of order on raw A V cube N. But keep in mind that we mentioned earlier here that 2 is unitless and oh my god, please, there's an error here, please. Here was supposed to be N, not K, please. Here was supposed to be N, I'm sorry. Here was supposed to be N. Then N is unitless as well. N is as well unitless. Good. That therefore implies I'm going to have the units of all of these. 2 is unitless, so the units of E is going to be kilograms meters squared per cubic seconds. All that on raw. What is the unit of raw? It is kilograms per meters cube. Then the area is in meters squared. Then V, the speed, is in what? Is in meters cube per cubic seconds. Good. Then this N is unitless, as we all know. So we can see that this K, this kilograms, they can cancel. This meters squared, they can cancel. This is cubic meters and meters cubed, they can cancel. Then seconds, the -3, they can cancel with this. So at the end result, we have our answers to be what? 1. That therefore implies that K is what? Is unitless. Great. That therefore implies K is unitless. So thank you guys for watching, and please, you can only watch all our other videos. You can only watch the complete solution to this particular year if you are a subscriber, if you subscribe to our channel and you follow our Facebook page. We shall leave the link in the description below. Once you've clicked the subscribe button and you've liked this video and follow our Facebook page, you shall have the link to watch the complete solution to this paper. And please leave a comment down below if you find contents like this useful. Thank you, and see you.